So cheetahs are moving incredibly fast with an incredible amount of force on their legs. We talked about the beginning about how you study injuries like lower limb injuries in animals. Is this a problem for cats and dogs as well that are running at these crazy speeds, or they have some more adaptive ability that prevents this? Or
Okay, let's come at this from a direction that will seem out in left field, but is going to answer your question. So the prey animals, by and large, zebras and all the other hoofed animals, because they're plant eaters, they need to carry around a lot of digestive fluid and a lot of bacteria and other microbes, many thousands of species of microbes, to break down the cellulose in the plant matter. Because eating plants, most plants have cellulose cell walls, and we don't have an enzyme to break down the cellulose. No mammal has the enzyme to break down cellulose. So with the zebras and other relatives, all horses and cows basically and their relatives, recruit these microbes to do the breakdown for them. So it's a sort of almost a symbiosis. The host mammal is saying to the microbe, okay, I'm going to give you this large, wet, warm space that you can float around with hundreds of billions of your species and breed freely, and I will give you lots of food, and all I want from you is to biochemically break this food down and release what are called volatile fatty acids, which the mammal can then use as an energy store. So the consequence of the anatomy is that all herbivorous animals have relatively large bodies. I mean, just think of the size of the body of a horse or a cow. And that's partly because they've got this voluminous gut, absolutely huge gut, that they have to carry around. So if they want to move fast, they've got two problems. One is holding the weight of the gut off the ground, and secondly, moving it around fast. As when you're either fast or long distances, because a lot of these animals have to migrate because their food source moves around. So they've got this problem of having this huge body relatively, and they've still got to move long distances very efficiently. So what they do is make major changes in their legs, essentially lose as many fingers as they can, because that's when I don't have a hammer with me. I usually do this thing with a hammer. I don't have a hammer. Imagine this is a hammer and this is head down. If you're trying to swing it like that, so you've got a really heavy foot, you're trying to swing it like that, that's about as fast as you can go, just holding it with your fingertips. If you put the head at the top, all of a sudden you can whistle that backwards and forwards. Try it with a real hammer for yourself. It's quite an effective demonstration. And it's part of the explanation why the prey animals essentially lose their toes, because the toes are weight at the bottom of the foot. The other thing they do is lengthen the lower part of the foot, because these are the skinnier bones. And then they can use the tendons that we use to curl the fingers. They use it the other way. They stand on their toe like this, and these tendons running at the back are now big springs that they can bounce off. So they save a lot of energy of moving their legs by reducing the number of fingers, because that's weight at the end of the leg, and then bouncing off their toes. And the trade-off is that the lever system that this now becomes puts incredible forces on the bones down here. And so most of the breakages in limb bones of the herbivores, the ungulates, is bones in the hand, lower part of the leg. And essentially, if they break a bone there, they're fatal. So what they've done is essentially reduce the weight of the foot as far as they can, and use these springs to bounce off to conserve their energy or assist with their locomotion, because they're not too worried about having claws and paws to be able to deal with prey. The way they deal with their prey is entirely with the face. Just put the face down and chew it. And so their body form is entirely different from the carnivores, because the carnivores still need this. And then within the carnivores, you see a couple of different ways of adapting, and we've already mentioned them. You've got the sit and wait carnivores, which are largely the cats, and they've got big feet. And then the dogs also go to fairly light feet, and they're adapted for running long distances, and they use their faces as the killing machine. So that's quite a nice circle, if you like. You've got both animals, both carnivores and herbivores, responding to mechanical constraints on their form, but in different ways. The shape of their legs and the way their legs work is very much constrained by basic principles of physics and mechanics. That makes sense?
Yeah, definitely. And actually, I'd like to continue along that vein of looking at the distributions of forest and things like that. You sent me a bunch of attributes that cats and dogs have. The first one is the backbone, the spine, which
that's part of the story I've just told, is that the ungulates, the prey animals, ungulates, this part of the finger, the last bone in the finger is called the ungual phalanx. What ungual is, so it's a Latin origin word, but it gives the ungulates, the hoofed animals, their broad name, because they all run on the tip of that phalanx. Backbones are also part of the story because the ungulates, again, because of this large gut that they're carrying around, tend to make the back not entirely rigid, but pretty rigid. So a horse is not sort of doing this with its back as it's running, whereas a cat, and certainly you'd see it in videos of the cheetah, what the cheetah is doing is it curls up this way, as when the back legs kick in, it straightens right out. So it's really using the large muscles of the back coming this way to push with the front legs, and then kicking backwards to drive off the back legs. The ungulates tend not to do that. That's not quite true, because there is some mobility that we tend not to have right at the base of the spine, right where the spine meets the pelvis. And so the back legs of horses and cows can be moved a bit by tilting the whole pelvis, but they certainly don't bend their whole backs the way that the dogs and cats do, because their backs are basically a beam with a great weight underneath it at the gut, and so the back has to be stiff and strong to be able to resist that weight dragging it down.
So the spine in probably most animals are four-legged, and the spine basically supports just hanging weight between the limbs, right? Yeah, and then so that's weird for humans then, because we went up on two legs, and the forces are totally different then.
And all the other vertebrates on the planet are looking at us and saying, "Oh, they odd. They stand upright. Well, what's that all about?" Because I mean, if you go back into fossil history, we derived from animals that were more like mud puppies or lizards, using all four legs, the backbone pretty much horizontal. And what mammals did with that is, instead of having the legs outwards, they pulled the legs underneath, and that put them in a totally different mode of locomotion, where the backbone, instead of oscillating from side to side, so it's the clown way of moving, now they're oscillating their back up and down. That drives.
I see.
And that's exactly how dolphins and whales swim. They've still got this upward and downward motion, which is why their flukes are flat and not that way like a fish's tail.